January 2018 multiple choice questions 21 through 24. Number 21. Quadrilateral ABCD is inscribed in circle O as shown below. If the measure of angle A equals 80 degrees and the measure of angle B equals 75 degrees, the measure of angle C is y plus 30 and angle D is x minus 10, which statement is true? Well, you know that there's 360 degrees in a circle. And any way you split it, even if you don't draw a diameter, if you draw any line, the two arcs are still going to add to 360. And these angles are inscribed. So if I draw a line here, okay, this arc and this arc are going to both equal 360. This angle will equal half of that arc, and this angle will equal half of that arc. So what that means is these two angles have to add up to 180. Okay, so x minus 10 plus 75 equals 180. X plus 65 equals 180. X equals 115. Okay. And then that means that these two angles have to sum to 180. Y plus 30 plus 80 equals 180. Y plus 110 equals 180. Y equals 70. And they're both there in choice 4. A regular pyramid has a square base. The perimeter of the base is 36 inches. So we have, drawing a square base, and I'm going to turn it into a pyramid. And so if the base is 36, this has to be 6 by 6. And then, oh, just kidding. The perimeter of the base is 36. So 36 divided by 4 makes this 9. Ooh, almost. Okay. And the height is 15. What is the volume of the pyramid in cubic inches? So, the volume is 1/3 length times width times height. So the volume equals 1/3. Let's see, I'm just thinking here. We've got inches and cubic inches, so there's no conversion here. I just wanted to double check on that because we're kind of getting up there to the numbers of questions where they tend to pull those kinds of shenanigans. All right, so 1/3 times 9 times 9 times 15. And I got 405. The volume equals 405. Choice 2. Okay, and just take a breath and pause and read it again and make sure that you didn't miss anything. This is a pointy figure, so we have to have 1/3 in our equation. Just like when we did the cone question earlier in this set, number 7. Again, if you don't have 1/3 in your equation, you're missing something. All right, question 23. Oh, we have a right triangle with an altitude drawn, and I know it's an altitude because it's perpendicular to the hypotenuse of the original triangle. In the diagram below of triangle ABC, angle ABC is a right angle. AC, segment AC equals 12. AD equals 8. That makes this 4. I don't know if that's going to be helpful or not. And altitude BD is drawn. What is the length of BC? So here's our X. So when I look at this, we have our medium and we have our small, and then the outside is our big triangle. And right away I can see on the medium triangle that I only know one thing, and so I cannot use the medium triangle. I have to use the big triangle. Big over small. The hypotenuse of the big triangle is 12. The hypotenuse of the small triangle is x. Okay. I know the short leg of the small triangle, so I'm going to put that on the bottom. And it turns out that the short leg of the big triangle is x. So x squared equals 48. You can hear the train in the distance. And so when I simplify that radical, x equals the square root of 48. Now this is multiple choice, so you could actually put all 4 of these into the calculator and see which one gives you the same decimal as the square root of 48. But the biggest perfect square hiding inside of 48 is the 16 times 3. The square root of 16 times the square root of 3 is 4 radical 3. The answer is choice 2. Okay, and last but not least, number 24, in the diagram below, 2 concentric circles with center O and radii OC, OD, OCE, and ODF are drawn. OC is 4. OE is 6, so that makes this 2. Which relationship between the length of arc EF and the length of arc CD is always true? Okay, so the whole thing is 6. These are similar sectors. Big over small is 6 over 4. So what do you think the ratio of the arcs is going to be? The ratio of the arcs, big to small, is going to be 6 to 4 as well, or 3 to 2, which is the same as 1.5. So there's a scale factor of the small one being multiplied by 1.5. Okay? So, which is always true? The length of arc EF is 2 units longer than the length of arc CD. No, this is not an addition problem. This is a proportion problem. So there's going to be a ratio involved, not addition. The length of arc EF is 4 units longer than the length of arc CD. Again, this is not an addition problem. When you say it's longer, you're adding. This is a proportion ratio problem. The length of arc EF is 1.5 times the length of arc CD. There it is. If you're dilating this sector, this is going to be 1.5. How do I know? Because 6 over 4, big, or image over pre-image, if that's the way you want to look at it, or big over small, is 3 over 2, which is 1.5. So we're going with 3, and it's not double.